So we've talked about linear inequalities before, but now we're going to talk about quadratic inequalities and solving quadratic inequalities. So in our last lesson, we talked about solving a quadratic and how we would find maybe two different solutions for x. We would find two different roots. If we solve a quadratic inequality, what's going to happen is that instead of an equal sign, we're going to see a less than or a greater than sign, or greater than or equal to. We're going to see an inequality sign. So we can still solve inequalities by factoring. There are some complicated ways to do this, but I do usually just teach this in the simplest way that I've seen. So what we're going to do when solving quadratic equations, we are finding the values of x where y equals 0. So we're actually finding the intercepts when we solve a quadratic. If we're solving a quadratic inequality, we're trying to find the intervals for x where y is greater than 0 or where y is less than 0. So you're familiar with some of these signs, greater than or less than. And whatever sign we see in our original question, we're just going to follow through with that sign. So if it's just a greater than sign, we'll use that. If it's greater than or equal to, then we'll use greater than or equal to throughout the answer. So what this means, it's similar to what we've already seen. X squared minus 4x plus 3 is greater than 0. What that is asking you is this parabola on the left, where would it be greater than 0 vertically? So when I look at this graph, anywhere from here up is where this parabola would be vertically above 0. So we want to talk about sort of this section of the graph and this section of the graph. So we do use our factors, and we still use our factors like we've seen before. X minus 1 equals 0, so we know x equals 1. And this factor from over here, x minus 3 equals 0, so we know that x equals 3. Those are our intercepts. So we do have these intercepts. But what we're asking you is, when would this graph vertically be greater than 0 for this question? So our answer to this question would be anywhere from here down and anywhere from here up. So that's why we would answer it that x would be less than 1 or x would be greater than 3. Both of those areas, greater than 3 and less than 1, that is where our graph is above 0 vertically. If you were given the exact same parabola, but you're asked for where the parabola is less than 0 means from here down. Vertically, where is this parabola less than 0? And that actually occurs in between the 2 points. So this parabola is only less than 0 in this section of it, from here to here. So we would say x is in between 1 and 3, and that would be our answer to the inequality. So let's practice a few, and it's just kind of the terminology. There is some factoring still. What I need to do first, I need to find the intercepts. So I do need to factor this. I need to find out what multiplies to give me negative 5 and adds to give me 4. And I know that x minus 5, plus 5 times x minus 1 would give me 5 times negative 1 is negative 5, and 5 minus 1 is 4. So I still write this in the same way. I like to use a graph or a little sketch to answer these questions. So this is asking you, where is this quadratic or this parabola greater than 0? So we do need to know what the x-intercepts are. And we can take each factor, just like we've done before, and set it equal to 0. And we know that our x-intercepts are negative 5 and positive 1. So we really do need to have a little sketch. It doesn't have to be super accurate. I just want to see what it would look like. This would be an intercept at 1, and I would have another one at -5. So this parabola is obviously going to have a vertex maybe somewhere over this way. I'm not even sure, but I'm not too worried about the vertex. What I want to know is, where is this parabola vertically going to be greater than 0? So what we can see is that anywhere greater than 1 or less than -5, these are the areas of this parabola that vertically it's going to be greater than 0. So what we can actually have as our final statement is that the areas where this parabola is greater than 0 would be the interval where x is less than -5 or x is greater than 1. So if we look at the next one, I think what most students find difficult about this might be the factoring. This looks like we have some pretty big numbers. I would, again, probably just try and do trial and error. I'm going to use the exact same inequality sign. Less than or equal to, I'm going to make sure I use that all the way through my solution. So in the front, what would give me 6? I know 3 times 2 is 6. And in the back, what would give me 20? 4 times 5 is 20. I could do 2 times 10. I'm not sure, but I check. This would be -15 and -8. So if I subtract both of those numbers, I actually do get -23. I do need to understand what the roots are or the x-intercepts are. Remember that we make little mini equations when we're trying to find our x-intercepts. I take each factor and set it equal to 0. I solve this like it's a little equation. And some of you might not need to show the steps. You can just look at that and know that this will be 4/3. And you'll know this one will be 5/2, but just to show you why, you move the 5 over, divide by 2. Oops, so I get 5/2 as my 2 intercepts. And you might panic and you're like, oh my goodness, this is going to be difficult because they're fractions. This means 1 1/3. This means 2 1/2. So this one is larger than this one. I'm just drawing a sketch, so don't get too worried about the sketch. I just want to draw a little sketch of this parabola. It's right side up. I go through 4/3 and 5/2, and I'm not even worried. I'm just drawing it to get the concept of how this parabola looks. I have a parabola that's, kind of symmetrical along those x-intercepts. This is asking me, though, this is what's very important. For which values of x are the y values of the function less than or equal to 0? Vertically, where is this parabola less than 0? So what I see when I look at that, where is this graph less than 0? Well, it's all of these points here that go along just the bottom part of this parabola. So that is basically anything in between 4/3 up to 5/2. So my answer for this is, therefore, the values are for x are anywhere in between 4/3 and 5/2. So it's in the middle, in between them. So I put my x in the middle, and this is less than or equal to because I'm using a less than or equal to sign. I had one in my original question. So this becomes my solution to where this parabola is vertically less than or equal to 0. Okay, and then we can make the equations more complicated. One thing you always have to know when you're dealing with factoring, maybe I would use distributive property here, but I'm going to have to bring all of my terms to one side so that it is less than or greater than 0. I always have to have all the terms on one side. I need to have a trinomial, or I need to have my quadratic equation all tidied up together. Something else that I can do is, that might make this easier, I could actually divide all of these terms by -2. So this is a harder equation, I know, but because I can divide the left side and the right side, I'm allowed to do that because I can divide both sides by -2. What it's going to do, it's going to make my equation look a lot easier. But remember, when you divide by a negative, I'm going to have to switch my inequality sign to the other direction because I divided by a negative. So this becomes my equation. I had to simplify it. I had to tidy it up. I tried to simplify it as much as I can. So this is asking you, for which values of x is this quadratic greater than, vertically, greater than or equal to 0? So one thing we'd need to know first, to be able to sketch this, I need to know what my intercepts are. So I would factor. So I could factor in this form what multiplies, it's a simple trinomial, what multiplies to give me 12 and adds to give me -7. 3 times 4 is 12. And if they were both negative, I'd get -7. But then I need to find and state my intercepts. So my x-intercepts are, would it be easy enough just to say x equals 3 or x equals 4? So if I draw yet another little sketch, because the sketch really helps me picture what I'm doing, I have, they're really close together. So 3 and 4, let's say this is 3 and this is 4. I would have my parabola would come down, and I don't even really care where the vertex is, but this is my parabola. And I have x-intercepts 3 and 4. This is asking me, where is this parabola greater than or equal to 0? Vertically, in what section is this parabola above 0? So the only areas that this parabola is above 0 would be this piece and this piece. And they are going to continue to go wider and wider and wider forever. So basically anything less than 3 or greater than 4, in that case, or less than or equal to 3, greater than or equal to 4, in those two cases, this quadratic would be greater than or equal to 0. So my therefore statement would be anywhere that x is less than or equal to 3 or x is greater than or equal to 4. And that would be my answer, or my solution to the inequality. So there's a little summary at the bottom. If we're using the less than sign, then the values are between the roots. You'll have a value is less than or equal to x, is less than or equal to some other value, or maybe you're just using less than signs. That is what happens when something is in between the two roots. If you're looking for where the values of x are going to be outside the roots, that's when we have values that are greater than 0. So our answer for this section would look like x is less than some value, or x is greater than some value. We could also use less than or equal to symbols if that's what is in your question.